Determine the hydraulic system diagram.
Lao Shi, can I ask one thing?
What's the question?
Lao Shi, how many chapters you will teach us? Up to chapter 9 or more chapters?
Can you write down your question in the dialog box? Analysis and selection of hydraulic seat. It includes the determination of the oil source and the actuators, speed regulating method, the oil line circulation mode for the second analysis and selection the hydraulic circuit. Below the main circuits, which have sensitive effects on the main performance of the main flow, which must be determined firstly and according to the working future and the performances. It includes it includes the hydraulic system of machine gears, speed regulating, speed exchange circuits, because the speed range, the speed characteristics, and other factors. We can according to their performances or other characteristics and choose the appropriate hydraulic circuits. Last, we should determine the hydraulic system diagram. To design the whole hydraulic system, the designers should combine and arrange the above circuits and add some components if necessary. So in this process, it must be paid attention to the aspect of safety, stability, and so on. We will go to an example. Introduce how to design a hydraulic system. So we go to the line point 1.4 calculation and the selection of the hydraulic components. Lastly, we should select the pump according to the maximum working pressure and provided flow rate. Working pressure and flow rate we have done them in chapter 1, calculated above. I guess you have finished your homework 1, which is related to the pressure and the flow rate. So in this section, a proper pump can be selected from product samples. For the sake of safety, the cruising times must be with a rated pressure 20% between 20% and 60% higher than the maximum working pressure or pressure reserve, but with the rated flow rate just meeting the maximum flow rate to avoid a steady loss of power. Then we should select the valve. The, the principle for selecting a valve. The specifications for the valve components must be determined according to the maximum pressure of the hydraulic system and the practical flow rate through this valve. The rated pressure and the flow rate of the selected valves must be higher than the system working pressure. Note that the flow rate through the valve must be increased if necessary, a low higher than 50% of the rate flow rate to avoid exceeding pressure loss. Heat, heat generation and load. To choose the throttle valve and speed regulation valve, the maximum stable flow rate must be exerted to meet the design requirements. Stable is the experiential values of the pressure loss in the inlet oil line for different system configuration, such as the simple system with the gel throttle speed regulating components and the pipeline. The overall pressure loss is between 0.2 to 0.5 for complex system with speed regulation valves and pipeline. The overall pressure loss is between 0.5 to 1.5. In the node section, we should select the valve arrangements. There are three types of arrangements for hydraulic equipment. One is the module type, two is the manifold plate type, and the last one is the integrated lock. For the first one, the module type, which structure, feature, and so on have been introduced in the chapter of hydraulic control valves. So for the manifold plate type, the manifold plate is actually a second installing plate for hydraulic components. The plant type valve components are mounted on this plate by bolts, and the oil line between components are actually the machined hole in the plants. Last one is integrated blocks. This block is anniversary block, so the designer can mount a paper plating on one of each side and place time valves on the other three, like manifold pump. The oil line are formed by bolt hole on the block. Usually, a hydraulic system consists of several integrated blocks. 9.1.5 performances for hydraulic system designer. Firstly, we should check in of the system partial loss. Partial loss includes traction loss along the pipeline, local loss in the pipelines, and tube is produced by a valve component. The partial loss of a lung or local is calculated from the involved expression shown in the chapter 2. While the local loss of the valve components can be obtained from the product samples. When the practical flow rate Q, flow rate Q, and the Qn is the rated flow rate or nominal flow rate. Then this is the C, the partial loss, and this is the nominal partial loss. The actual parallels, and this is the nominal parallels. This is the actual flow rate. This is the nominal flow rate. Then the practical partial loss equals the nominal parallels multiplies the ratio of practical flow rate to the nominal flow rate, the squares of this item. So we can calculate the partial loss by this equation. Taking of the temperature rate according by generation. According to a heat balance principle, when the dimension ratios of three sides of the reservoir are between 1 to 1 to 1 and 1 to 2 to 3, the OER is 80% that of the reservoir higher, and the reservoir is in good maintenance condition than package. The chloride, this is chloride. Here is the input heat with the effective volume of, and the unit of the temperature rise degree. So the temperature rise can be calculated in this equation. This is the input heat, and this is the effective volume. Once the chicken oil temperature rise surpasses the allowable values, a proper cooler must be set in system. The allowable oil temperature rise in a reservoir is different for different membrane. Generally speaking, the flowable oil temperature rise rate T in the reservoir, usually between 25% and 25 and 30 degrees for yellow machine tools, and 35 to 40 degrees for engineering machinery. Then we should draw in a working diagram and technical documents. Working diagrams must incorporate hydraulic system figure, assembly drawing, and the assembly There must be exists a list of components attached to the hydraulic system figure. The system assembly figure is the construction and erection drawing for the hydraulic system. Generally, the technical documents include the explanation of design calculation, manual to the use and maintain, contains all parts, standard parts, and the universal parts. Our table of outsourcing parts. So we should introduce a design example of hydraulic system. To design a hydraulic system, we first should analyze the working conditions. Then we can determine the main parameter of the actuator. Then we can design the hydraulic system. Selection the hydraulic components. Finally, we should check the performance of the hydraulic system. This is a typical example for a hydraulic system to design. This section is to study the hydraulic system of single slider, multi-spanning rolling machine tools. First, we should focus on this table. Here, cutting force. The 30,000, the overall gross wage. 9,500 strokes, 100 micrometer. Piston age working speed is 50 micro. The right here, fader, and retraction facility. 5. Working force facility velocity 0.405. Acceleration time 0.2 seconds. The friction coefficient right. The effect that are procured. The coefficient of 0.2 and the frictional motion, which means the friction, the first moves period and the friction coefficient is 0.1. The efficiency of the cylinder is 0.5. So the dynamic slip weight is required to achieve such a working. Because it's rapid feed, startup, working feed, unblock fever, and rapid retrench, and the last one is stop at the original position. So the analysis of the working conditions. Cutting force, which is also the only force, whose direction is horizon. Then the inertial force, the fractional rise, and the fractional motion against the tidal wave, and calculate first. Firstly, we should calculate the shear force. on the initial force is the mass multiplied with the acceleration. So the mass is this is the gravity acceleration. This is the increasement of the facility, the increasement of the below. This one is the mass. This one is the mass, which equals the force which divided the gravity acceleration. So, and this is the increasement of the speed. We can see the increasement of speed 5. This is the acceleration 10. Acceleration 10. Yeah. So we can acceleration is the speed with the unit of meter per minute. So we should introduce to the unit of meter per second. So we should multiply 60. So we can get the initial force. It's about 404 Newton. Then we can calculate the friction of rest, which means this machine in the startup period, the friction can be calculated by this equation, which equals the coefficient of friction of rest multiplies the normal force. So you can show the normal force is the gross weight. Normal force is the gross weight, and the coefficient of rest is 0.2. So we can get the friction of rest. The same friction of motion. This is the coefficient of friction motion. This is the normal force, which also equals the gross weight. So we can get the friction motion, which equals 10,050 Newton. Have no diameter. Cylinder high working conditions, startup, acceleration, deceleration, working and rapid change. So the load cylinder in each work steps are listed in this table, where the back pressure in the oil return chamber is liquid. Load and speed diagrams are bigger A and bigger B. Also, we can pay attention to this table. In the state up period, the load combination is the friction of rest. So the load is 1,900 Newton. this one. And since the mechanical efficiency is 0.9, so we can get the thruster because this force divides the mechanical efficiency, so we can get the thrust. In acceleration, frictional rest invented to the fraction of motion, which is this one, 950 Newton, 900, and this is the initial force. Initial force we have calculated in there. So here's the total force equals the sum of the initial force and the fraction of motion. So it's this one, and we can calculate this one. This one equals 0.1 equals this one. In the acceleration period, since there is low working components, so the total force equals the friction of motion. This one, calculate this last. In the working speed. Firstly, we have the friction of motion. So this one is 0. This one is 950 Newton and equals Ft. Actually, you can get this number divided 0.1 plus the last process. Rapid retraction. Total force equals the friction of motion. So number is this one, and we calculated this rapid force. The figure is the load and the speed diagram of the cylinder. The force is the see the force. This is the state up state. State up state. The force is this one. The force is this one, and then the acceleration. Then the deceleration. Deceleration, and we can get the force. Then this is the working speed. Then we go to the rapid retracting. What's the force? Go to zero. Go to zero, then in the opposite direction. Also, it is where instead of but in the opposite direction. So this force is one. Then of it and the uh, fraction of rest is converted to the fraction of motion. Then this one is so this is loader diagram is either to the key feed oscillatory. The rapid retreating motor it should their then in the opposite direction will fix with the oscillatory of 5, then the oscillatory goes to there. Next, which is the determination of the main parameters of the actuator. Let's see the piston pressure, back pressure, and the area of cylinder. The cylinder area can be calculated from the stress rate working phase period. In the working phase period, the force equals the mechanical efficiency is calculated in the previous section. Here, working phase, the thrust is this one, which this one. So this one is equals in this period. This is the this is the this is the control for working pressure. This is the working pressure, and this is the back pressure. The area of working. See the back pressure area, so we can get. We consider the back area equals half of the pressure equals half of the working area. So we can get this equation. Then we'll send the working pressure for this one part. The back pressure is 0.8. So we can get the area of working. This one. The area is the circle. There is circle. So we can get this one. There's the diagram. This one for outside A1 and Y1. So we can get the diagram. then we can get this diagram. F, D, and D must be corrected to the standard values according to this standard. So we choose the integrate number. Integrate number. So D equals 7 micrometer. And this D equals H micrometer. Then the practical equation area of these two chambers for cylinder are this one. This is the back area. The cylinder, the piston in the cylinder, this form. This is D. This is D. So get the area A2 is calculated in this equation. The pressure flow rate and power H each working step showing table line 2, 5 and the working conditions are then for basic figure line 2, 5. This is the pressure flow rate and power rate each step consideration. With the back pressure, the state up there. The one is the working pressure. Flow rate. We calculate this one. Different process there. Input flow rate are different. Input power, and we also calculate the work efficiency level, which is similar to the above figures. This is the flow rate, the pressure, the power. This is the flow rate. Flow rate is this cave. This cave. Flow rate. You see the flow rate. Flow rate here. This one. This one. This is the rapid retract speed. So it is minus this one. This is the number. Wait. Yeah. Same method we can draw the power design of hydraulic systems. Selection of hydraulic circuits. Design of hydraulic system and the selection of hydraulic valve. hydraulic circuit. From the working condition diagram, we can clearly see the features for the designed hydraulic system. Low power, low speed of the slipway, small change of the working load, so an entrance throttle bearing sockets. Observer can be that for speed of control circuits. Volume supply and pressure regulating method can also be determined after the speed of control circuit. A back pressure value such on the oil return line. Design of hydraulic system. From the above analysis and design scheme, the principal charge for hydraulic system can be determined by reasonably combined each chosen sockets. Selection of hydraulic valve. This is the principal charge of the hydraulic system. This is the principal charge of hydraulic system with major valve. 9.2.4 Selection of hydraulic components. Pressure. For the pump the two critical parameter is the pressure and the flow rate. The pressure for the maximum working pressure of a cylinder. Described in the previous section. This section we should calculate we should calculate the flow rate. The maximum flow rate provided by the two pumps is this one. If the leakage in the return line is supposed at 10%, then the input flow rate of cylinder, then the overall flow rate of the two pumps is this one. So the overall flow rate of the two pumps can be calculated in this equation. This is the maximum of flow rate, maximum flow rate, and this coefficient includes the leakage. So we can get the overall flow rate. From the pressure and the flow rate calculated above, we can choose pumps table. This one can be adapted. The deliveries of this pump and the large pumps. This one. Then we can choose the motor. According to the involved motor product, we can select steps motor Y 100L 6. The valves and auxiliary elements. The valves and auxiliary elements can be selected according to work pressure and the practical flow rate. Then pipeline according to the built-in sizer code drawn here table and that diameter of micrometer, out diameter of 80.2 and specification of the component I will choose in this section. This is type inspection of the component for the module walls. The output flow rate percentage for the reservoirs. The volume of the reservoir can be estimated from this equation. Maximum inside equals 7 bacteria node of the volume of the reservoir. Value can be correct to a standard value of 250. There's a community is the standard. Last process is to check performances of the hydraulic system through the concern the pressure loads and oil temperature line. Okay. This is the end of chapter 5. Of our class. Then we will go to experiments and highlight that. First, below the total scores of all this course is 100, and the final exam account for 50 scores, and the usual performance including the homeworks review, the experiments accounts for another 50 points. So we search the extra point column, and you can use the extra point column to improve your grades. You can get maximum 5 points in this extra point column.
老师, when to do it?
You can select one of the following 2 items. You can introduce your review.
When to do this? 老师.
Okay. Please wait. I'll introduce the rules of the extra point column. You can introduce your review, and if you volunteer, you can get 5 points. If I ask you to do this, you can get 3 extra points. Also, you can explain the homework 1 or 2. You just choose 2 questions in homework 1 or 2 in total. Below, in homework 1 we have 4 questions, and in homework 2, we have 3 questions. So you only choose 2 questions in homework 1 or 2, and then explain how you solve this question to us. If volunteer, you can gain 5 extra points, and if I ask you to do this, you can gain 3 extra points. Please load. It doesn't matter if your answer is correct or not. You just need to explain how to solve the questions in the homework.
Lao Shi, where is the question? The questions are from the previous homework.
Yeah. You can share your PowerPoint, or you can share your screen. You can share your screen.
Lao Shi, when should we submit it?
Which one submit?
Those extra points for this. On which date we need to submit it?
In this class, now you can allow any volunteer to introduce your review or explain your homework. Any volunteers?
Laushi, it has to be right now.
Okay, you can begin right now.
I'm asking if
Who want to be the first one?
Is it the review about this class?
No. We have a assignment. Do you remember? We have an assignment. Is a review
Yes.
about
Yes, Lao Shi.
is a review about the hydraulics transmission. Now you can introduce your review.
Laushi, can I start?
Okay, you can start. What's your name and student ID? I'll make notes.
Lao Shi, can we start
My
after
student
him?
ID. My student ID is 62.
Write down in the dialog box. Please write down in the dialog box.
Okay.
And then you can begin.
62. The last number is 62. Okay.
Now,
I did about the history of the hydraulics.
Lao Shi, homework 1 and homework 2 was mathematics.
Did you see it?
Yes.
okay, you can go one by one. And okay, now who is the speaker? Now who is the speaker? Is the last number? The last number is 62.
62.
62. Okay, you can begin.
Okay. The history of hydraulics. Wait, Laushi, let me put the.
Okay.
Did you see my number? Okay.
Bob,
Yeah.
so what are you going to do now? Is it now or
you can begin.
Yeah, it's now.
what's going on?
Laushi, I cannot. Okay. the history of the hydraulics. This is what I did. So we can start with who invented the hydraulics. No exactly people know who invented hydraulics were invented, but the systems were created from the great works of Blaise Pascal, if you can see it, and Joseph Bramah and Leonardo da Vinci. Leonardo da Vinci was a very good artist, and Galileo. So they found their place in the modern world. So it was first of all famous in ancient Greece and Rome. So what they started, their aqueducts provided the way of cities to get reliable supply of water, as you know, to get the hydraulics going. They carried through the easy access with the help of Aquandan civilization to settle the areas immediately beside the major water resources. It was very impressive. So they started with the Turner of Palinos. Okay, I'm gonna try to make the summary so that we continue the class. So the Romans and the Greeks were advanced in the engineering skills. So after building these tunnels, this one, they went on roads and bridges and aqueducts. Many are still used today. Uh, even the Chinese, they use it. So the Quanzan system on their own could have inconsistent flow rates because it was in ancient times, so it was not really consistent. So to combat this, the Romans installed regulation devices in the steam and created reservoirs at the ends to bring more reliable water supply to the people, and that could store some water for the city in 3 or 1 month. So how our understanding the hydraulics changed in the 17th century and 19th century. At the start, the hydraulics advanced with Simon Stirling discovering hydrostatic paradox and the study of non-moving water. Galileo, the observation of gravity, as you know, he developed this, gravitation acceleration, which played into the movement of water. His students included Evangelista Torricelli, is Italian, who applied the knowledge of liquid jets and liquid barometer. So as you can see here, so Blaise Pascal started the work on mechanical calculators and became one of the first two inventors of the device. He made contribution to mathematics, as all you know, Pascal's triangle, very many things. So he also developed the hydraulics fluids, the buildings of Torricelli, and studied on the vacuum space. Pascal came up with the law in this year, and the Pascal law says that the pressure applied to a fluid inside a closed system, the pressure will be equally transmitted in all directions. I think Lao Shi said this when we started. This is a very big principle about hydraulics. So to continue summarizing, this guy Daniel Bernoulli published a book called Hydrodynamica, in which he described how water behaves under a certain condition and how it reacts to equilibrium, pressure, and speed. Bernoulli's principle was based on studies of energy conservation. And then Bernoulli worked closely on mathematician Ronaldo Euler, who has discovered the Bernoulli's equation, which is very difficult, by the way. Me too, I don't understand. But maybe Laoshi is gonna teach us. So he developed several important hydraulics equation and hydraulic turbine. Yeah. So I'm not gonna talk about the effects. It's just the review about what I did. But I talked about the effects of temperature on pipes determining the flow rate. And this is the study of Isaac Newton and the development of rotary engine and hydraulics accumulator by George Armstrong. I also talked about the introduction and regulation of hydraulics mining. So in the modern application of hydraulics, I added it as something for extra to talk about because it's very interesting. So hydraulics are systems because they're adaptable, you know. So furthermore, I continue to talk about how people choose their hydraulics fluid with various purposes and characteristics in their mind, like viscosity, density, and environmental impact, and weight cost. So hydraulics repair and information. Hydropower is one of the most widely used and oldest forms of energy. Its application ranges from irrigation to construct equipment and heavy machinery. It is widespread that you probably have some type of hydraulics equipment in your home or office, anywhere you go. So, what makes up a transmission hydraulics component? So, I also talked about this as also an extra. So, I talk about the pump, the transmission pump. That's exactly what you think. It pumps fluid, and we study in the previous chapters in this class. And we talked about the torque converter. The torque converter seems like a simple concept, but it is very complex in application. It's a fluid coupling. It converts to torque, and the torque converse connects to the engine transmission in terms of torque and delivery, meaning it regulates and allows the constant speed of the engine to be transferred through the transmission and the usable form. I'm sorry here, unusable form. One turbine spins faster in relation to the engine, causing more fluid pressure to against other turbine, as you know about the Pascal's law here, which turns the transmission, and there is no direction mechanical transfer of motion. It all happens based on the motion of fluid in the conveyor. Is all what makes the main what makes up the transmission of hydraulic components: the pump, torque converter, and the valve. So I hope you understand the brief history about hydraulics, and I hope you all enjoyed my review. Thanks.
Okay, thank you very much. It's very interesting. Now the student last two number of student ID 50
Is
70 70
62.
62
77.
77
That
77
is 70.
can begin your
All right, Laushe.
okay.
Can you see here? My friend, he already discussed about what is hydraulic system and the other parts, the history of the hydraulic system. But I want to I want to explain a system how it's work really. And this example is basically from our assignment 2, question number 3. Maybe you can guess it, right? So I will try to explain how the system work actually. So this system is basically a principle of hydraulic system, and if I want to explain what is a hydraulic system, lately is the of hydraulic all system is expressed by Pascal law, Pascal law, which are state that pressure uh, um, exerted anywhere upon an enclosed liquid is transmitted. The way the work of hydraulic system, basically liquid from a pump to the other place where it should work. So it's all about pushing liquid, pressuring liquid to work from a small force, like from 10 Newton force to like 10 Newton force to maybe 1000 Newton, right? I mean 1000 Pascal. So this is our main purpose of hydraulic system, how it's work. So basically it's all about liquid, pressuring liquid, and using a little force to work bigger. So like 5-pound force existed against 1 inch square meter, and then internal pressure is 5 Pascal, right? And then this pressure acting against 10 square inch area, like what I want to explain is like it's a place, it's the area, and we can force here only 5 Newton, right? But if we use a hydraulic system, with this 5 Newton force, we can get like 500 Newton force work. So this is basically the hydraulic system. Am I right or not, Laoshe? Are you hearing me?
Oh yeah, I can hear you.
Okay.
Since
So
you can
yeah,
continue.
you say?
Since some students hasn't submitted their homework, so I will not make comments on your answer. You can.
You mean? Sorry, Laoshe, I didn't get you.
Since some students didn't hasn't submitted their homework, so I can't make comments on your answers.
Okay, I get you. Okay, so let's continue. So what I'm talking about, like if I want to explain this system of hydraulic system, so here we can see a pump, and then there have two valve, and this area is like a place where the liquid will go. You mean there have some liquid, they really they get the pressure from the pump, and they took it from here to here, and then the system in the system. So they took it in the system. So if you give here like 5 Newton force, you can get work here maybe for 500 Newton force. So this is the huge force which we use to get some work. So if I want to explain here from the pump, is there have a valve here. This is the valve, and then here we can see the workforce backward movement of the fluid, and then and one of the operate circuit, we can see here there have a circuit. This is circuit is called 413 DCV valve, will control all the action. So this part will control all the action in this system. And then the middle blocker will both side of the pump and receive at any piston of needle, any piston of the needle. And finally, in the last part, the valve will assure that the return fluid, the fluid what we use in the how to say it, in the pump. So the final valve assured that the liquid will come back in the pump again to get the next force. So this is the way how this system work. And if I want to explain that, and here all hydraulic circuit consider of a reservoir pump and relief valve 3, and the directional control valve, single acting cylinder connectors, and the lines. The system use where the cylindrical piston is returned by mechanical force. So with the control value in neutral pump, flow pass through the valve and the back to the reservoir again. So extended the road, if the valve is returned to nature, the oil, we are talking about the oil, I mean the liquid, the oil trapped in the cylinder and holding it in the fixed like piston, you can see holding in the fixed piston. And while pump flow is returned to reservoir, shifting the valve in the opposite direction, permit all the oil to pass through the valve back to the reservoir again. So this relief is limit the system pressure to the preset amount relief valve, and commonly incorporated into the directional control. So this is the way how this system really work. I guess you understand, Laoshi. I tried my best.
Okay, it's really a very good job you have done.
Yeah, thank you, Laoshi.
Okay, then the 64 student, the last two number of student ID 64.
Yes, Laushi, can you hear me?
Oh, okay, I can hear you. Now you can hear.
Okay, Laushi. Laushi, Laushi, can you give me just 1 minute? I'm just.
Okay, I can wait. And we both can wait.
I don't know how to open the back camera here. Laushi, can you give me next?
Laushi,
Okay. Who
Can you
want
give me
to?
next?
me,
Because
Laushi, I will go for it.
What's your student ID? The last number.
70, Laushi.
Okay, you can begin. And the 7 there.
Okay.
Okay. And you can begin first. And
Laushi, can you see my PPT?
okay, I can see you PPT. Now
Okay.
you can begin.
So, Laushi, once our subject is about hydraulic and pneumatic device, I will explain both of them. Hydraulic and pneumatic device are all around us. They are used in manufacturing, transportation, in moving equipment, and common vehicle we see every day. As we can see here, we have a picture of one engine, we can say like that. There is a motor, oil pipe, oil pump, oil tank, oil coker, and the hydraulic valve. So what are some examples of a hydraulic and pneumatic system? The brakes on your car are hydraulic operated. The garbage truck that passed weekly by your house uses hydraulic power to compact the trash. Your mechanic uses a hydraulic lift when working on the underside of your car. Pneumatic systems are equally widespread. Trucks and buses are actuate the brakes. Spray painters use compressed air to spread paint. Ever been irritated in the morning by the sound of a jackhammer? That's pneumatic mechanic hard to work using compressed air. So right now I will introduce about hydraulic system. In 1647, French mathematician Blaise Pascal developed a principle of fluid mechanics, known as Pascal's law. It states that when pressure is applied at any point in a confined fluid, the pressure will increase equally at every point on the container. As convoluted as the principle may sound, it's the base of operation of hydraulic system. How does hydraulic system work? Hydraulic system use a transmission network to carry a pressurized fluid that drives hydraulic actuators. The hydraulic fluid gets its pressure from a pump driven by a prime mover, such as an electrical motor or a gas, diesel engine. The pressure in oil is filtered, measured, and pushed out through the transmission system to an actuator to perform some action. Afterward, the fluid returns under low pressure to reservoir where it's cleaned, it filtered before returning the pump. And here there is such kind of advantage of hydraulic system, such as use a small component to transfer large force with consistent power output, has the actuators that are capable of precise positioning, is able to start up under heavy initial loads, produce even a smooth movement under varying loads since the fluids are not compressible and flow rates can be accurately controlled with valves. And there is such kind of disadvantage of hydraulic system. Pumps, valves, transmission networks, and actuators are expensive. They can pollute the workplace with leaks, which may cause accidents or fires. They are not suitable for cycling and high speeds. Hydraulic fluids are sensitive to dirt, contamination, and must be tested regularly. Ruptures of high pressure lines can use injuries. So right now I will talk about what is a pneumatic system. Pneumatic systems are like hydraulic system, but they use compressed air instead of a fluid to transmit power. They really on a constant source of compressed air to control energy and actuate motion device. Here we have this picture that we can see here. We have filter, we have motor, pump, oil tank, pressure regulator. We have here duration control valve that's from this side to this side. And we have here load and actuator. What are the components of pneumatic system? Air compressor. The air compressor draws air from the atmosphere, pressurizes, is store the compressed air in a tank for release the transmission system. Primer drive. A primer drive such as an electrical motor gas-powered engine provides the power to end air compression. We have also air tank actuator. We have such kind of advantage of pneumatic system like their efficiency. The design is simple, the ability to operate the high speeds, and there is such kind of disadvantage to reduce the power, noise, and the roof movement. So actually, this was the introduction about the history of hydraulic system and pneumatic system. Thank you, Laushi.
Your presentation is very attractive. Thank you.
Thank you,
Now,
Laushi.
okay.
My last number 70, Laushi.
Laushi, can we start now? 6-4.
6-4 can begin. Okay.
Okay, Laushi. Laushi, someone's mic is on, maybe. Laushi, someone's mic is on. It's annoying.
Now, what's the problem?
Laushi, I'd like to discuss about assignment to question 1 and 3.
Okay, you can.
Okay, Laushi, here in question 1, Laushi, someone's mic is on.
Hello, but I can't find. Okay, okay. Now you
Okay,
can
Laushi.
begin.
Yeah, Laushi. For the first question, it says area, here given area A1 equal to 30 centimeters square and A2 equal to 12 centimeters square. And for the load, we have given 30 kilonewton. And here this statement says the area of control piston is 3 times as big as the area of core. And for this, we need to find out the driven pressure, that is PV, and we need to find the maximum pressure. So for maths, okay, let's find the solution. Here the maths specially works with the law of Blaise Pascal. Blaise Pascal states that A pressure change at any point in a confined, impressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. And for this, according to Pascal's law, we know force is equal to pressure into area. And first of all, for the force F1, we find the pressure, that is P1, and here we find that P1 is 1000 Newton per centimeter square. And again, we know from this law that pressure times area equal to driven pressure into area. From here, we find the driven pressure, which is the 2500 Newton centimeter square. And in the questions, as it says that, let's go back to the question. As the question says that the area of control piston is 3 times as big as the area of core. So we have divided the area of A1 piston by 3. We get the 10 centimeter square, and from this we find out the maximum pressure. So here is number 1, and I'd like to next talk about question 3. Here it said that add a direction control verb to make motor rotate forward, backward, and stop at any position. And in this, for this problem, we would like to also state the Pascal's law. Here, 413 DC valve hydraulic circuit is given, and 413 DC valve means it's 4x2 way solenoid valve with a poppet design. And for this, for forward rotate, inward, for the valve number 1, if for first position, in the valve number 1 will remote motor forward of return, which makes fluid toward the reservoir. It will helps us to, from valve 1 will get the fluid towards the reservoir. And the second position, which is in the middle, is block position, that will block both sides of pumps, and reservoir and motor stops at any position and it's working. And for the third valve, third position, which ensures motor will rotate backward of return, make a fluid towards reservoir. Actually, this is all the about 2 examples, and it's really annoying. Someone again has started his microphone.
Okay.
Laoshi, is it possible to present?
Yeah, go on, Saleh.
Can someone mute the mic of those people, please?
Hello, Laoshi.
Okay.
Laoshi, are you here?
I can hear. You can.
Okay. So my research is on application of hydraulic transmission systems. First
Please
of all,
wait. Please wait. Now we have a break. You can make your presentation in the following class. Okay. Now
okay,
we have
Laoshi.
a break.
All right,
Break.
all right, no problem.
We will have break for 10 minutes.
Okay,
All right,
Lashe,
Losi.
thank you.
Okay. Muatatema.
So Hans, stop calling me. Call your countrymen. Tell them to mute their mic.
Ni hao muatatema. Wasiang ni.
Get
For such.
এই ইমরোজ
What's
মামা
up, huh?
তোমার মিউট করো ক্যামেরা। লাবা নিজামালা।
Talk to them, man.
Yeah, I'm talking.
এ ভাই কেউ ইমরোজরে কল দে, ইমরোজরে একটা কল দে। ইমরোজের নাম্বার কার কাছে আছে? এ প্রত্যয় শ্যামল একটা কল দে না। এগুলো কি বেটা পোলা পাইন, এগুলো ক্লাসের মধ্যে এগুলো করছে বেটা। প্রত্যয় একটু রেসপন্স কর, একটু পারলে একটা ফোন দে। ইমরোজের নাম্বার কারোর কাছে থাকলে কাইন্ডলি একটা ফোন করতো ভাই, একটু কাইন্ডলি একটা ফোন কর, ফোন করে একটু ওকে একটু বল, কারোর কাছে থাকলে কাইন্ডলি একটু ফোন কর।
Okay. Now we continue. The last student can make your presentation.
Yes, Lashi. Can I start? Lashi, can I start?
Oh, okay. You can start.
Okay. First, I would like to start with the homework. So I'm gonna explain one part of the homework, and then I'm going to start my own presentation. Okay. All right. So, please, can you see the PPT?
I can see you, PPT.
Okay. So I want to explain question 2 and question 3 of the homework. So in the question 2 of the homework, it says we should explain the working principle of the hydraulic system, this hydraulic system. So when we look at this hydraulic system, we can see that firstly it has a hydraulic position valve and therefore flows. Yeah. Yeah.
You have two devices connected, so the voice is coming 2 times.
What?
Yeah, now it's clear. Go on.
The hydraulic system has a position valve and therefore flow stopping at any time is available. This
Hey.
this valve is a four-way valve, and if you look into the PPT, we can even see it here. The selection of the valves. This is the valve used. It's a four-way, two-position valve, which means stopping of the fluid at any time is available. It also has a pressure valve that helps to safeguard the system in case of any overflow of the fluid. The pump will continuously supply fluid safely since it is a safeguard valve. In the first position valve of the eight-quarter valve, the flow is controlled by the meter out circuit. From piston, it moves forward. There's no motion in the middle piston. And finally, the third piston retracts and
I
is
was
controlled.
asking.
What? Okay, and it's controlled by the meter circuit. The third question, we're asked to find it. Okay. We're asked to add the control valve to make the motor rotate forward, backwards, and stop at any position. So we are supposed to put a valve here to help to simulate the hydraulic system to push the motor forward, back, and to stop. So the valve that perfectly suits this system is still the four-way valve, which is here. Okay. So as okay, hold on 1 second. Okay, so as we can see here, the four-way, three-position valve, it says stopping at any time is available, indicates return manner, and when actuator moves in two-position direction. So with this valve, we can move the system forward, back, and can also stop. So we use the four-way valve here. So in the description, we use the 413 DCV valve to obtain forward, back, and stop in any position operation. This valve has 4 parts and 3 ways. The first position, A, which is this part of the valve, will rotate the motor forward. It returns fluid flow towards the reservoir. The second position, B, which is the middle part of the valve, is the part that blocks the position. So is the middle of the block position, which will block both sides of the pump of the reservoir, and the motor stops at any position it's working. And then the last part, C, in this third position, it ensures that the motor will rotate backwards and return the fluid towards the reservoir. So that is my understanding of the homework. For my presentation, I would like to share the screen again.
Okay. Your explanation for the question is very clear. Thank you.
Thank you, Lashe. So my research work is on application of transmission systems. Actually, transmission systems have been something I've been interested in for some time now. A transmission system is referred to the methods used to transfer engine power to drive a wheel using hydraulic fluid. It simply means, if you look at the basic principle, it means using a hydraulic system or a hydraulic pump to convert mechanical energy from its prime into a pressure energy of flow of liquid. So it is simply the use of fluids, which can be oil, hydraulic oil, or hydraulic other hydraulic fluids to produce mechanical energy. So when we look at transmission, the hydraulic transmission system, it can be used in many fields. Examples of fields it can be used in is the diesel hydraulic transmission, which is mostly used in cars. It's also used in railway locomotives, in the movement of railway parts. Also, it can be used in hydrostatic transmission. And also, the hydraulic transmission can be used to drive systems in a hydraulic cylinder. The hydrostatic transmission also makes use of hydraulic transmission systems. So let's look at the basic knowledge, since this is quite far-fetched. Energy is transferred by changes in fluid pressure energy. So when we want to maximize or amplify an energy or convert one energy to another using fluid, we use hydraulic pumps, which converts the energy the fluids bring into mechanical energy in order to do work. So hydraulic pressure element is converted into mechanical energy by means of a hydraulic actuator. This hydraulic actuator could be a hydraulic cylinder or a motor, thereby driving the working mechanism to achieve a linear or reciprocating motion and rotatory motion. So what this is trying to tell us is that with the change in the hydraulic pressure of the hydraulic fluid or the motor system, we can achieve the movement of power in a straight line, which is linear, or the movement of power in a rotatory motion. The liquid used for this medium, the liquid is called the working medium, and generally mineral oil. So mostly mineral oil is used in a hydraulic cylinder or motor in order to achieve hydraulic transmission. There are two forms of application of hydraulic transmission. There's the practical application, and then there's the theoretical application. When it comes to the theoretical application, hydraulic transmission has many outstanding advantages. So its application is very, very extensive. We can use it for more things that when it comes to the theoretical knowledge or application, such as the general industrial plastic processing machinery, pressure machinery, machine tools, and other machine transmission applications like in railway lines. When it comes to agriculture, we can see the application of hydraulics in cars or tractors that are being used to harvest these goods. If you look at these tractors that are used for harvesting in the agriculture sector, most of them make use of a lot of hydraulics in order to make arms that can move or claws that can help harvest materials from one place to another. When it comes to flood control gates and dam installation for civil engineering, hydraulic pumps are mostly used, because with hydraulic pumps, the fluid is not being affected by other environmental factors such as salinity, which is salt water and stuff. For instance, if we have a dam and we want to control the coming in and going out of water, it is very advisable to use hydraulic pump or fluid, since this fluid is inside a hydraulic pump and won't be affected by any environmental or the water itself. It is better to use that than to use any electric motor or something that can end up being affected by the water. When it comes to power plants and turbine speed control devices, such as nuclear power plants, it's advisable to use hydraulic pumps, since nuclear power plants are very reactive. And since we have reactive metals like uranium and radium, which can easily just explode at any time, it's better to use less inflammable devices. For instance, if you want to work in a nuclear company and you are using motors that are using diesel to work, it's very easy for the nuclear plant to explode. But then if you are using hydraulic pumps and hydraulic motors in order to get transmission of energy from one mechanical device to another, then it's gonna safeguard the company and safeguard the work you are doing. So I think for now that will be a little enough for the theoretical application. When it comes to the practical application, we have the use of these hydraulic pumps to gain rotatory motions. For instance, if you go to a manufacturing company, you will realize we have we like we study in machine design, we have two uh two finishing methods where we have one part where the material that is supposed to cut the surface of the material being produced, the tool, is rotating at a very high speed. Now, these rotations can also be achieved with hydraulic pumps. So these tools can also be made with hydraulic transmission systems in order to gain power so that we can make better goods in our manufacturing companies. This is my knowledge I have gathered so far in this research. And since the deadline is 12th May, Lashi, I think maybe you should give us more time till 12th May so that we can add more knowledge to what we are doing. Because I think it's better for us to do the work and really understand it in a long span of time than to just do it in a haste and then walk out. So thank you very much, Lashi. That's my presentation.
Okay, thank you very much. Your
My,
presentation is very good.
thank you, Lashi. My student number is 55.
Okay, okay. Hello, hello. Now the last student ID, last number of student ID, 66
Okay, Lashi,
begin
thank you.
begin.
I would like to introduce in assignment two in question number two. First of all, I would like to introduce some introduction and the main basic things of the working principle of the hydraulic system. First of all, I would like to say some important things about that. The control movement of parts, control application of force is a common requirement in the industrial requirements industries. The prime movers can provide a various movement to the objects by using mechanical attachment like screw, jack, lever, rack, pinions, etc. However, these are not only the prime movers. The enclosed fluids can also be the prime movers, provided the motion force, objects, etc., and also substances. The specially designed enclosed fluid system can provide both linear as well as the rotary motion. The high Mankind control forces also be applied by using this system. This kind enclosed fluid basis system using pressurized incompressible liquids as transmission media are called by hydraulic system. The hydraulic system work on the principle of Pascal's law, which says the pressure is an enclosed fluid is uniform all the direction. The Pascal law is illustrated as in figure. Just now, I'm talking about the working of the principle. The hydraulic system consisted a number of parts. Its proper functioning. The schematic of the simple hydraulic system is shown here. There have some parts like a movable piston connected to the output shaft in an enclosed cylinder, storage tank, filter, electrical pump, pressure regulator, control valve, leak-proof closed loop piping, that's etc. There have also some a double-acting cylinder, four-way, three-position, graphic symbol, non-return fixed deliver hydraulic pump. Actually, the output shaft transfer the motion or force. However, all the other parts help to control the system. The storage tank is reservoir for the liquid used as a transmission media. The liquid use generally high density incompressible oil. It is filtered to remove the dust or any other uh, unwanted particles and then pumped by hydraulic pump. The capacity of the pump depends on the hydraulic system design. The pumps generally deliver consistent volume in each revolution of pump shaft. Therefore, the fluid pressure can increase indefinitely at the dead end of the piston until the system fails. The pressure regulator is used to avoid such circumstances which redirect the excess fluids back to the storage tank. The movement of piston is controlled by changing liquid flow from port A and port B. The cylinder movement is controlled by using control valve which direct the flow The fluid pressure is connected to port B to raise the piston, and it is connected to port A to lower down the piston. The valve can also stop the fluid flow in any of the port. And there have some also things like the leak-proof piping is also important due to the safety, environmental hazards, and economical aspects. There have some important things about the things that pump will constantly supply the fluids, and there is pressure relevant valve which help for cell ground system, and flow is controlled by meter out of circuits. And we have some application of hydraulic system, like the hydraulic system mainly use precise control of largest forces. The main application, the hydraulic system can be classified into 5 categories, like industrials, mobile hydraulics, automobiles, marine application, aerospace application, etc. If I say first in industrial application, plastic processing machinery, steel making, and primary metal extraction application, automatic production line, machine tools in paper industries, loaders, crushers, textile machinery, and R&D equipment and robotic system, etc. About the mobile hydraulics, tractors, irrigator system, and earth moving equipments, materials handling equipments, commercial vehicle turning, boring equipments, rail equipments, building and construction machinery, drilling, rice, etc. In automobile, it is used the system like brakes, shocks absorbs, steering system, windshield lift, and cleaning, etc. And marine application, it is mostly covers ocean going vessel, finishing boats, and naval equipments. And lastly, I would like to say the aerospace equipment. Their equipment a system used for radar control, landing gear, brake flight control, and transmission, etc., which are used in the airplanes, rocket, and spaceship. This all for my explanation. And my name is Himal Hasnat Ahmed, and my student number is GJ2019210066. Thank you, Lashi.
Okay, thank you. Your interruption to this question is very clear and good. Thank you.
Thank you so much, Lashi.
Okay, then the next one.
Yeah.
Okay, what's your ID? Oh,
5-7. 5. Hello.
all right. Oh, hello. You can begin. Oh.
Good afternoon, everyone. My name is Batra Yugesh, and I want to explain our homework 2. So let me share my screen. So I want to start with question number 3. So as you can see in this system consists this hydraulic system consists of 4-way 3 position or 4x3 directional DCV valve. So in this system we are asked that add a directional valve so that this system will work efficiently and in 100% way. So in this system we can use 4x3 DCV with tandem center. So what is the use of tandem center? If you ask this question, then I want to reply that in this 4x3 DCV with tandem center. So when the hydraulic pump uh, pumps the fluid from the reservoir, so look at the center, tandem center. If So it have three direction. So for first direction, the motor can move forward or backward, and the help of tandem center, the fluid will again pass through this. You can see this. You can see here. So fluid will pass through this tandem center, and it will again go back to the reservoir. So I think so. In my opinion, for this question, the DCV should be 4x3 with the tandem center. So 4x3 position or 4x3 directional control valve should be used with the tandem center in the system to make motor rotate forward and backward and stop at any position. So for the question number 2, in this hydraulic system consists of a single rod end double acting cylinder. So the main part of this hydraulic system is the cylinder, because the fluid always fluctuates as the fluid moves within the cylinder. So it have a single rod end double acting cylinder with two check valve, and it have 4x3 DCV. It have 4x3 control valve, direction control valve with float center, and it consists of non-adjustable pressure relief valve. So it is not adjustable, so the fluid can pass with its limit. And the main part of the hydraulic system is the unidirectional variable displacement hydraulic pump. The system consists of unidirectional variable displacement hydraulic pump, which is used to pump oil throughout the system. The system has single rod end type cylinder where the hydraulic fluid is injected and bypassed, and the 4x3 valve with float center is used to change the oil direction whenever it is necessary. So this was my presentation. Thank you.
Okay, your presentation is good. Thank you. Okay. Hey, any volunteer? Are there any volunteers? Okay. The last two number of student ID, 2H. You can begin your presentation.
Good afternoon, Lashi.
Okay, I can hear you. You can begin.
About our presentation or homework 2. No. question number 3. Here we can see in this picture, this is the this is one of the fluid flowing system and background and open circuit with 413 dcv valve. It has 4 parts and 3 ways to perform. And first position, forward of return it toward reservoir, and third second position to which will be blocked both side of pump and reservoir and motor stop at any position. It is working. And next one is ensure motor
Oh, okay. Hello. Thank you. Oh, okay.
Lashi, also I want to do that, but I also want to that's a third question.
You can continue.
Hello, Lashi.
No problem.
Okay, so Lashi, then I also continue this. Just a second.
Oh, what's your student ID?
Okay, Lashi, and Lashi, I'm going to talk about this question third here. Here you see that we have a 4 on 3 DCB bulb to achieve forward and backward stop in any position operation. We have to operate circuit with 4 on 3 DCB bulb. It has 4 port and 3 ways to perform. First position will remote motor forward to of return makes fluid towards reservoir. Second position, which is in middle, is block position, which will block both sides with pump and reservoir, and motor stops at any position it is working. The third position, which ensure motor will rotate backward or of return maker fluid towards reservoir. Thank you, Laushi.
Okay.
Laushe,
Now,
I wish to present the question in homework, the question number 2.
okay, you
So the question number 2 is saying explain the working principle of the hydraulic system. As I did it, I can explain that in pump we continuously supply that fluid, and there is a pressure rate valve which help for safeguard the system. In the first position of 9 V4, valve flow is controlled by meter out circuit. And the piston will move forward, and the middle position there will be no motion, and in third case the piston will react, which is controlled by metal out circuit. Thank you, Laoshi.
better.
Hello, she. Can you hear me?
Oh, okay. What's your student ID? Okay.
Lashi, I want to explain question number 2. I'm Hassan M. Murad. My student number is ZZ 2021001094. Hydrochloric system introduction and working principle. The control movement of parts or a control application of forces is a common requirement in the industries. Their operations are performed mainly by using electrical machines or diesel, petrol, and system engines as a prime mover. These prime movers can provide various movements to the object by using some mechanical achievement like screw jack, level, rack, and pinions extra. However, these are not the only prime movers. The enclosed wheels can also be used as prime movers to provide controlled motion and forces to the object or substance. The specially designed enclosed fuel system can provide both linear as well as rotary motion. The high magnitude control force can also be applied by using this system. This kind of enclosed fluid-based system using pressurized incompressible liquid as transmission media are cancelled as a hydraulic system. The hydraulic system works on the principle of Pascal's law, which says that the pressure is an enclosed fluid is uniform in all the directions. The Pascal's law is illustrated in the figure. How the machine is working. The hydraulic system consists a number of parts for its proper functions. The scheming of a simple hydraulic system is so. It consists of a movable piston connected to the output staff in an enclosed cylinder, then filter. The output shaft transfers the motion of forces, however, all other parts helps to control the system. The storage fuel tank is a reservoir for the liquid used as a transmission media. The liquid used is generally high density incompressible oil. It is filtered to remove dust or any other unwanted participle and then pumped by the hydraulic pump. The capacity of the pump depends on the hydraulic system design. These pumps generally deliver constant volume in each revolution of the pump shaft. Therefore, the full pressure can increase indefinitely at the dead end of the piston until the system fails. The pressure regulation is used to avoid such circumstances which radiate the excess fluid back to the storage tank. The movement of piston is controlled by changing liquid flow from the port 1 and port B. The cylinder movement is controlled by using control valve which decrease the fluid flow. The fluid pressure line is connected to the port B to raise the piston and it is connected to port A to lower down the piston. The valve can also stop the fluid flow in any of the port. The leak-proof piping is also important due to safety. Hydraulic pumps. The combined pumping and driving motor unit is known as a hydraulic pump. They can be of two parts. Centrifugal pumps. Centrifugal pumps use rotationally kinetic energy to the driver deliver the fluid. The rotationally energy typically comes from an engine or electric motor. Number two, reciprocating pump. The reciprocating pump is a position plug pump. It is also known controlled by using control valve which direct the fuel flow. The fuel pressure line is connected to port B. Thank you, Lucy.
Okay, thank you. Your explanation good. Thank you.
Thank you.
You have gained the extra 5 points.
Laushi, I want to go now.
Okay, what's your student ID? The last number?
65. The last two digit is 65.
Hello. You can begin.
Laushi, the third question is add a direction control valve to make motor rotate forward, backward, and stop at any position. So the components are the pump, valve, blocker, and valve for the return. We can see in the picture the pump will give power to the valve 1, then there will be a forward and backward movement in this section, then where I have noted the number 1, and after that the circuit with 4x3 DCV valve will control all the actions, and the blocker at the middle will block both sides of the pump and the receiver. In the middle there is a blocker and it will block the movement of the fluids, and lastly the valve will make sure that the fluid return and move as the system says. So the circuit will control all the movement of the fluids. Thank you, Loshi.
Loshi, I want to go now.
Your student ID, the last two number is 18 19.
Loshi, my student ID is last two digit is 65.
5. Oh, hello. 65 is.
Loshi, I want to go now. My student number is last two digit is 19.
Okay. Next.
Okay, Loshi. So
Kloshi, I want to explain question number 3, and here's the hydraulic circuit. Maybe you can see.
Okay.
I'm sorry, I cannot rotate. I cannot rotate the camera. So this is my front camera. Okay. So here's the circuit. This is the pump, and I want to explain hydraulic circuit. Here is the totally circuit. We see here is the processing, the 1, 2, and 3. Here is the 3 circuits, and this is the locker. This is the pump, and now I'm gonna explain how it works. Okay, so here's a pump. When a machine pump the fluid, then the fluid enter the circuit 1, 2, and 3 gradually. So to archive forward, backward, and stop any position operation, we have to operate circuit with this 4BDCV valve. Okay, it has 4 parts, 3 ways to perform. Okay, here is the 3 way, 1, 2, and 3. Okay, so first position, first position is 1, and it go to remote motion forward of return moves fluid toward reservation. Okay, the second position is the 2. Here's the 2, so which is in the middle. Okay, which is in the edge. Here is in the middle. Okay, is a block position, which will block both sides of pump. Okay, reservation and motor stops at any position in working. Okay, and here is the third position. The third position, which ensures the uh, motor will rotate backward and return move fluid towards the reservation. Thank you, Loshi.
If there are low volunteers to make presentation, we will continue the experiment, and we will continue introducing the experiment and the final exam.
Okay, Lausha.
Okay. And then I'll share my PowerPoint. It's about the experiments and the final exam. Okay. Now we go to the experiments. The experiments are simulation experiments. So you should go to this website. Okay, I'll share. You share mine. Okay, this is the website of the experiment. This is the user and this is password. Please do load. Change the user and the password. Owning login. Then you can see the experiments. They are 13 experiments. You should only choose 4. You should only choose 4 experiments in the next 2 weeks. Every week you should finish 2 experiments, and experiment one, this one. Experiment 1 is compulsory. You must do it. And how to do this? First, this is requirement, and this is the step. This is a step. Okay, we go to the slide. In the 12th week, you should finish 2 experiments, and the 2 experiments must include experiment 1, this one. Experiment 1, the performances of the hydraulic pumps. And then in the 13 week, you should also finish 2 experiments. Below experiment 1 is compulsory, and the other experiments are optional. You can choose them by interest. So below in the next 2 weeks, we will not have class. Please pay attention to this requirement. We will not have class in the next 2 weeks, and you should finish 2 experiments in total by yourself. And if you can't, we go to the website. Such as we go to the experiment 2. You can see you can see the experiment step of this picture. This website have a clear experiment to you, so you can.
Noloshe,
Okay.
is this video you are talking about in Baidu Disk? Is it in English language or Chinese?
Oh, okay. This video have low volume. Have low. Okay. First, I will upload the video, which I will
Or you'll upload later?
upload the video in which. Okay, and now is everyone can shoot download this video.
Lao Shi.
Okay,
Lumpy, we cannot see the page. Can you please upload it in the WeChat group?
Okay. Now you can hear me. You can. Now I have uploaded the two documents. You should download them. Uh, do you see the two documents in the dialog box? Do you see the document?
Sorry, Laushi, can I speak?
Okay, you can speak.
Oh, okay. I'm going to present an hydraulic system. I want to talk about how an hydraulic system is working.
Oh, please
Yeah.
wait, please wait. I will, please wait, please wait. I will first introduce the experiment and the file exam, and then you can make your
Oh, okay, Laushi.
Okay, please wait. If you can't download the experiment, the two documents, I will give the two documents to the header of your class. The header of your class. 风 the header of your class, and then he will distribute the two documents to you.
All right, Laushi, we understand.
Okay. Share the if you can't fit if you don't don't know how to make the experiment, you can see the video, which is the instruction. You can see I'll share.
Laushi, I think you can send this to link in our WeChat group.
The video. Video doesn't have audio. Okay, in the next 2 weeks we will have class and the instruction the video. Then I will share. And then the experiment evaluation sometimes for 15 points. You must submit experiment report for experiment one, just one, my mailbox. for this time. You must submit report of experiment 1. Although you should finish 2 experiments fast, you only submit experiment report of experiment 1, and the experiment report template to see the file in the notebook. Okay, and then is the final exam. 14th week. Remember, this time in the 14th, it's the last week. We will have final exam, and this exam will last 2 hours from 14 o'clock to 14 o'clock to 16 o'clock. Note, everyone must attend the final exam. Everyone must attend the final exam, otherwise you will fail this course. And this final exam is open book exam. So open book exam, you must write down your answer in A4 sheet. You must write down your answer in A4 sheet and scale it, then send a PDF document to my mailbox within 30 minutes of the end of the exam. Must send a PDF document to my mailbox within 30 minutes of the end of the exam. In other words, must send your email which contains the answer sheet PDF form. Send to my mailbox between 16 o'clock to 16:30. See the end of see the experiments and the final exam. Please note, everyone must attend the final exam. And this text. Okay. Now the one. Now the
Laoshi.
Okay. What's your question?
Okay. I think if you give us some example or some suggestion for our exam, that will be much clear for us, because the syllabus we know it's a broad, it's a huge work. So I think what about you will give us some example or some suggestions about for exam?
Oh, the final exam is similar to our homeworks. Each contains.
So everything will come from our homework, right?
Yeah. It contains the final exam. Contains 5 questions.
5 questions. So
5 questions.
all of the question is related to math or anything to draw.
Yeah. All the questions are similar to our homework 1 and homework 2.
All right. Only inside from our homework, right?
Yeah.
Okay.
4 questions. 4 questions.
4 questions.
Yeah, 4 questions is similar to homework 1 and homework 2.
Okay, Laoshi. Okay. Thank you.
Now everyone have downloaded the experiment steps and the experiment report. Don't.
Sorry, Laoshi, can I ask you a question?
Okay, you can ask the question.
Did you say that we need to submit the exam sheet 30 minutes before?
Yeah. You must send your answer sheet to mailbox.
Then if the exam will be only 2 hours, which means we have to do it in 1 hour 30 minutes. Could you please?
No.
Yeah.
No. So I think after 2 hours you will get 30 minutes to submit your paper.
Oh.
Yeah.
Okay, then
Extra 30 minutes. Okay.
oh, okay. Oh, thank you.
Okay, now the one who want to make the presentation.
Yes, Lao Shemi, please. I'm going to talk about an hydraulic system, how an hydraulic system works. Firstly, can you see my screen, please?
You
Okay.
Yes.
Yeah. This is an hydraulic system, and then in this hydraulic system there is a reservoir, there is a filter, there is a pump, a control valve, a retract and extend, and an hydraulic cylinder. This hydraulic system is a closed system. How it works: an hydraulic system used to use the pump to push hydraulic fluid through the system to create fluid power. The hydraulic fluid pass through the valve and flow to the cylinder, where the hydraulic energy convert back into mechanical energy. The valve help to direct the flow of the liquid and relieve pressure when we need it. How this hydraulic cylinder work? What is the main work of an hydraulic cylinder? Firstly, an hydraulic cylinder is also called linear hydraulic motor. It's a mechanical actuator that is used to give an unidirectional force through a stroke. It also have many applications, notably in construction equipment. Like I'm going to show you also an equipment, a machine that we use in construction, where we can see an hydraulic cylinder. Can everyone see those three places that this way? Can everyone see those three places that I show? Those are hydraulic cylinders. They are in machine. Exactly as we say, we can meet them in construction equipment. Thank you, teacher. Loshi, thank you. I finished.
Laushimi, I want to present mine. Hello, Laushi. Hello. Laushi, are you there? Laushi, can I be heard? Hello.
Okay, you can begin. I'm sorry, you can
Okay,
begin.
okay, Laushi, I will explain about a super open center hydraulic circuit, and then I will explain also the fundamental featuring of using hydraulic compared to machine for force and torque. So I will begin. Hydraulic machinery. Hydraulic machinery use like liquid fluid power to perform work. So this is the simple open center hydraulic circuit. You can see this one is hydraulic cylinder, the hydraulic cylinder, and this one is the reservoir. Hydraulic machine use liquid fuel power of performance work. Construction vehicles are a common example. In this type of machine, hydraulic fluid is pumping to various hydraulic motors, and hydraulic cylinder through the machine and become pressed according to the resistance present. Hydraulic system like pneumatic system are based on Pascal law, which states that any pressure applied to a fluid inside a closed system will transmit that pressure equally everywhere in all directions. For the fundamental feature of using hydraulic, as you can see, we have some force F1, F2, and then the popular hydraulic machinery is due to the very large amount of power that can be transferred through small tubes and flexing holes, and the high power density and wide array of actual that can make use this power. Mm, mm. I think that's all.
Okay, thank you.
Laushi, I want to present the next.
What's your ID?
Hello, Laushi. Hello.
Hello, what's your ID?
Laushi, I cannot present my work on the. I cannot share my screen. Can I just
ZZ.
explain?
The extra one.
Hello, Laushi.
L1. The extra one. L1.
Hello, Laushi. I cannot
Ahmed, you can send
present.
it
I
to
cannot
me. I
share
can
my
present for
screen.
you.
Lecture student
Send it to
L1.
me. I will present for you.
Okay. Let me.
No, Silas, she asked for your ID.
Hello, Laushi, can you see my screen?
Okay, I can see your screen. Okay, you can.
Okay. My name is Miyashitu. My student ID is GJ201921001003. Now I'm going to explain assignment, the history of hydraulic transmission. Here you can see too many information, so I can't go through line by line. I just want to show you the okay. Throughout history, people have always drafted toward the water. We built cities on major waterways and used them as thoroughfares. We used running water to power wheels that help us prepare food and fabric. Hydraulics, or the use of fluid power to run machinery, have been around for quite a while, for over 2000 years. Who invented hydraulics? It is to say exactly who invented hydraulics or when hydraulic systems were invented. Hydraulic systems have been created from the work of great minds like Bellasi, Pascal, Joseph Bramah, Leonardo da Vinci, and Galileo Galilei. Hydraulic eventually found their place in the modern world with wide-ranging and powerful applications. Here you can see the evaluation steps. The ancient hydraulics in Greece and Rome. And how our understanding of hydraulics changed in the 17th, 18th, and 19th centuries. At the start of the 17th century, the study of hydraulic advanced with Simon Stevens' discovery of the hydraulic paradox and the study of non-moving water, and Galileo Galilei's observations on gravity. Galileo studied gravitational acceleration, which played into the movement of water. His students included Evangelista Torricelli, who applied this knowledge to liquid jets and the liquid barometer, and Benedetto Castelli, who rediscovered the principle of community. So I just want to skip some because this information too much. The 19th century led to many advancements in hydraulics. 1. The effects of temperature on pipe flow and determining flow rate. Isaac Newton was studying various properties of fluids at this time. Then Gottlieb Ludwig Hagen conducted experiments to find the effects to temperature on pipe flow, even though he was working off Newton's base of knowledge. His results were within 1% of modern measurements. His experiments involved injecting sawdust into a fluid to see motion more clearly. Over in France, Jean-Leonard Marie was researching flow as well, but his work was about the flow of blood through the body. His research led to equations on laminar flow in piping. His work, along with that of Hagen, was used to develop the Hagen-Poiseuille equation. This equation states that the flow rate is dependent on fluid viscosity, pipe length, and the pressure difference between the ends. The development of rotary engine, the introduction and regulations, modern day applications of hydraulics. As the 20th century washed in, so did new varied uses for hydraulics. Hydraulics are popular system because they are adaptable, offering flexible hoses and small tubing, along with many different actuator types. The high pipe density doesn't hurt either. hydraulic repair and information. Hydropower is one of the most widely used and oldest forms of energy. Its applications range from irrigation to construction equipment and heavy machinery. It is so widespread that you probably have some type of hydraulic equipment in your home or office building. The remarkable engineers of the past paved the way of contemporary systems that adapted and grew to meet the needs of a modern world. Engineers at hard chrome specialists have more than 75 combined years of experience working with hydraulic pumps, valves, and motor repair. If you find that you have a broken hydraulic system and need repair, or want to learn more about hydraulics, hard chrome specialists can help. We are family owned and operated and strive to meet all your hydraulic repair needs. Thanks a lot, Taushik. The end.
Okay, thank you. Your presentation is good. Okay, you have got extra 5 points. Okay, the last chance for making presentation is for 5-1. Please load 5-1. You can make your presentation. 5-1.
Hey, Lauchi.
Okay,
Sohan,
5-1.
share for me the screen, Sohan. I've sent you my PDF.
Okay.
Hello, Sohan. Lauchi, can you hear me?
No, I can hear you. You can hear.
I've sent my PDF to Sohan because I could not share it. I'm waiting for him to share it for me.
Okay. You.
Can I read it, Lauchi?
Okay. You can send your PDF to Suhan.
Okay. Let me try to present it. Sohan, can you hear me, Sohan? 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 Hello? Lauchi, 1 minute, Lauchi. I'm trying to share the screen.
You can capture Suhan.
I can read it, Lauchi?
Oh, are you ready?
Yeah. 1 minute, Lauchi, please. Lauchi, can I read it?
If you can't share your PDF, you can just talk about it.
Okay.
Load it.
Okay, Lauchi, I'll start, Lauchi. According to the Pascal, when there is an increase in pressure at any point in confined incompressible fluid, then there's an equal increase at every point in the container. Hydraulic actuators are designed based on the principle Pascal law. To understand how hydraulic actuator works, let's take an example of 2 cylinders connected together as shown in the figure. Suppose one cylinder has cross-section area of 1 square meter, and the second one has a cross-section area of 10 centimeter. If the cylinder are filled with incompressible fluid and 1 unit of pressure is applied to the left cylinder, pushing the pump, actual liquid by 10 centimeter, then the resulting force acts on the right cylinder, pushing the piston by 1 centimeter. But with a force of 10 units, this means applying 1 unit of force produces 10 units of forces on the other side. I could not present my drawing because it's refused, but I can give a similarities of hydrochloric actuator are majorly used for a system. This is the drawing. Thank you, Sohan, for putting it. Can you zoom it, Sohan? You see, if when you put like a pressure of 10 centimeter, pressure is applied on a 10 centimeter, then it's eventually, this means on the other side, you apply the same force. I'll give similarity of hydraulic actuator are majorly used for a system which require very large forces, but not very restrictive on positioning and accuracy. I can give an advantage of hydraulic actuator. They can move moderate to heavy loads. Second, they are more efficient in delivery, better performance than others. Third, power to weight ratio of this actuator is high. I think when you are Laushi, can you hear me, Laushi?
Okay, I can hear you. What's the question?
I'm giving an example of hydraulic actuator here. Like the example I've given, the example I've given. When let's take example of the two cylinders you have on the drawings. One is as construction area of 1 square centimeters, and the other one has the construction area of 10 square centimeters. If the cylinder filled with incompressible fluid and 1 unit of pressure is applied to the left cylinder, pushing the pump by 10 centimeters, then the resulting force acts on the right cylinder also, pushing the piston by 1 centimeter. But with a force of 10 units, this means applying 1 unit of force produces of 10 units of force on the other side also. So I think, Laushi, that's what I've explained about the hydraulic actuator. Thank you, Laushi.
Okay, thank you very much. Your presentation. You have gained the extra 5 points.
Okay, thank you, Laushi. Thank you, Sohan.
Okay, this list is the student who have gained the extra 5 points. Congratulations. The left hand of this class before you finish your review or review your experiment. Use the Okay, class is over. Class is over.
Okay, Laushi.
Okay, class is over.
Class is finished, Laushe?
Yeah, class.
Oh, all right, Laushe. Wanna say goodbye?